Now, once you understand the component of the sales, quarter sales, now let's make this forecast model. First, the most simple, the forecast model is exponential smoothing method. So this exponential smoothing method, we calculate the forecast value in period t plus 1. So what I'm doing is explaining this. It's equal to the previous forecast value plus some fraction of the error from the previous forecast. So the goal is to reduce the error because the forecast always generates error. So how do we reduce this error from our calculation is the objective, right? So we are using many methods of measuring the error and then how to reduce this error. So here, some of the scared errors is kind of variance, right? The variance of the deviation from our expectation. And the mean scared error or root mean scared error. So yeah, the calculation is a little different, but the usage of this error is the same, identical, right? So once we get this, the exponential smoothed cells, then we'll calculate this alpha using solver, and then this alpha will generate the minimum error, right? The minimum error here in terms of percentage or just the magnitude of this error, right? And then how do we reduce the error at the minimum level, right? And then we'll compare this result to the forecasting model. Okay, then let's go here. Exponential, because of this equation doesn't work in the first quarter, and inevitably we start from the same, the sales, actual sales, right? And here, now we use this formula, right? Then here, the head is the exponential smoothing, right? D5 plus, now alpha, we'll calculate this alpha using solver. This alpha, we want to fix this because I'm going to drag down, and then times. Now here C5, right? C5, which is the actual sales, minus now the back data, using the back data, what could be the sales forecasted. Here now you use the same, right? D5, and then enter, right? But here it doesn't have any, we don't have any calculation. Let's just assume the alpha is just 1, right? Let's just assume the alpha just is 1. Okay, then let's drag down, all the way down to the bottom. We will forecast just one the quarter, doesn't matter how many quarters, but this case, if we don't have the additional the sales, we cannot go further. So here, now we have this forecasted, right? Now we got it. So these are the exactly same, by the way, right? You see here, exactly the same, right? That's why it covers the sales with this the exponential smoothing. But for example, if it is 0.5, now we have the different number here, right? Do you see? It's very similar, right? It's very similar. So this exponential smoothing, the sales using the exponential smoothing the method is now a little following this back data, right? But we cannot use this because it doesn't cover the seasonality, right? But anyway, let's calculate the alpha, the minimum alpha, right? The alpha that minimizes the this error, right? Of these two error. So we are going to use some Excel function to calculate this statistical the calculation of the formula minimum squared the error, and the minimum absolute percentage error here. So here, even I don't know the exact, I cannot remember the exact the function, but here some function can be used because the sum of this, right? Sum and divided by one, divided by one, divided by the number of the samples. So sum x and y 2 and open the parenthesis. Now I'm going to drag this cells down to the bottom. And then comma. Now this exponential smoothing the cells, right? And then divided by how many? Count. Here also the same, the n, right? So that helps you get this. The mean squared the error. This equation exactly the same as this. Okay. Now we can also calculate the mean absolute percentage error. It's simply, this is average. Do you see the average, right? And then we need absolute value here, right? Absolute error to remove the negative, the error result. So average, just simply average. Open the parenthesis. And absolute value. AVS function. Open the parenthesis. Now let's get this all extra cells, comma, and minus, oops, minus the exponential smoothing the cells, and then now divided by the cells again. And then let's close the parenthesis. Then now we have the minimum absolute percentage error, right? Error is the difference, right? Error is the difference between these two. So now 18% is the minimum, the mean, the absolute the percentage error we calculated. But how can we reduce this error at a minimum level? We can find this alpha, right? So now let's go to data. Solver. Do you see here we already have here set the objective G6, which is the alpha. We want to minimize this alpha, right? Minimize. And by changing the variable cell here, let's use the G5, which is the minimum squared error. We want to minimize, right, this variance error, right? And here I put the subject to the constraint. Here G5, this alpha, is here. Now this alpha is lower, equal, or lower than 1. And then, again, this equation is also greater than the 0, right? So let's put that the condition or constraint. Okay. And then just solve. Oops, it doesn't make. Let me just run again. Minimum G5. Oh, it should be definitely 6. And the solve again. Okay, let's start from again 1 and solver minimum and G5 and let's solve. Okay, we got it. So when the alpha is 0.28, then we can reduce the mean absolute percentage error or the mean squared error at the lowest level, right? But the result, as you can see here, is still, it shows, right? It's still just too much line on the trend, right? This model, the exponential smoothing method model, cannot represent this seasonality. It didn't consider the seasonality. So we cannot use the exponential smoothing model. But if your company you chose to analyze doesn't have the similarity, but based on this backdata testing, it follows the sales, previous sales, the line, then definitely you can use this the model. Now let's develop the forecasting model in the next exercise. See you later. Bye bye.